Good morning, welcome again. I'm here with another lecture on steel design. So in the last lecture, we have covered the parameters such as pitch, gauge, and end distance and edge distance. Today, we will carry forward after that. And if you haven't watched the previous video, then please watch the previous video so that you can understand this lecture. Okay, so let us continue. So this is the third lecture on design of steel structures. Steel structures, and then we will today study bolted connections अभी ख़त्म नहीं हुआ है और भी मुश्किल से और 2-3 लेक्चर लगेंगे, bolted connections ख़त्म हो जाएगा. So please bear with me क्योंकि ये बहुत important lecture है, important lesson है. Bolted connections is very important. Now from today onwards we are getting into some serious business. So yesterday, if you remember that I have told you that the minimum pitch is what 2.5 times the dia of the bolt and minimum pitch, and I have told that minimum end distance is equals to what 1.5 times the dia of the hole. Okay, this is dia of hole and this is dia of bolt. Now you can obviously understand that the dia of the bolt and dia of the holes are different. Okay, holes में क्या होता है, we provide some clearance. स्टील में अगर होल्स पंच किया जा रहा है, that means वो holes will not exactly be of dia of the bolt, that there will be some tolerance or we say clearance. Okay, so let us talk about clearances. Bolt hole clearances. Okay, so before studying about bolt hole clearances, you should know that there are more than one type of bolt holes. Okay, so types of bolt holes. First one is standard size hole. So first one is standard size hole. Second one is standard size hole कैसे normally just जैसा होता है उसको स्पेसिफिकेशन से नॉर्मल सर्कुलर होल. सेकंड इज ओवरसाइज्ड होल. ओवरसाइज्ड होल्स जस्ट स्टैंडर्ड साइज होल्स का जो होल्स होगा वो थोड़ा बड़ा होगा डायमीटर में. दैट मीन्स दैट क्लियरेंसेस विल बी मोर इन ओवरसाइज्ड होल. थर्ड वन इज शॉर्ट स्लॉटेड holes and fourth one is long slotted holes. एक short slotted holes कैसे दिखता है, ठीक है. और long slotted holes also look like short slotted holes, only the slots are longer in length. Okay, this is also like this. Fine. Achha. Now the bolt hole clearances which I will talk about is only for standard size hole, and if you want to know about the clearances of oversized, short slotted and long slotted holes, then you have to consult IS 800 2007. You have to open it. Okay, so now standards bolt hole clearances for standard size holes. So for for bolt of dia of 12 mm, the dia of the hole will be 13 mm. This is dia of the bolt, this is dia of the hole, and this is the clearance. Okay, fine. So if the dia of the bolt is 12 mm and dia of the hole is 13 mm, then what will be the clearance? Clearance will be 1 mm, right, plus and 1 mm, 14 mm. If it is 14 mm, then the hole will be dia of 15 mm. So it is also 1 mm. For 16 mm dia, the clearance is 2 mm. For 18 mm, the hole will be 20 mm. So the clearance is again 2 mm. 20 for 20, it is 22 mm. So 2 mm for 22, again plus 2. For 24, again plus 2. For after 24, when we reach 27, the clearance become plus 3, again plus 3, and this is again plus 3. So the maximum clearance is what? Plus 3 mm. Okay, so remember this, that if you can remember a range, then you can say that from 12 to 14. Okay, this is all including. Okay, including 12 to 14, the clearances will be plus 1 mm. Now and 16 to 24, okay, this will be plus 2 mm, and greater than 24, the clearances will be plus 3 mm. Remember, this is only for standard size hole, not for other holes. Other holes के लिए clearances अलग होगा. Okay. Now we are getting into now some serious business here, so please pay attention. Now I will discuss about the types of failure in bolted connections. Okay, the first one is shearing of bolts. Shearing of bolts means the bolt normally just shears. If you can imagine, then you can see that the bolted connection are obviously normally, I can say normally in shear. Okay, I will just draw the diagram. Now see, here there is a lap joint and a bolt is connecting this lap joint. Now when this plate is pulled here and this plate is pulled here, obviously the bolt here is in shear and it will invariably fail in shear, and the failure interface will be what? This plane, and the bolt जब यहाँ पर shear कर जाएगा तो कैसे fail होगा? यहाँ पे एक इसका टुकड़ा ऐसा आ जाएगा बाहर, and another part will be here. So this failure is what? Shearing failure. No, failure along the surface. No, what is shearing force? Force experienced along the surface of any body is called shearing force. So this failure is shearing failure of shearing of bolts. Now second failure is what? Second failure is bearing of bolts. Bearing of bolts. Bearing of bolts is nothing very simple actually. Bearing of bolts means simply the reduction in the material. Okay, the deterioration in the material. That is, एक bolt जब बहुत दिनों तक किसी कनेक्शन में लगा रहेगा तो उसमें तो वो स्टील टच हो रहा है कि नहीं. स्टील टच होने से उसमें क्या होता है कि मटेरियल उसका जो होता है it starts to deteriorate. This is the bearing of the bolts. This generally happens when the plate is of very high strength and the bolt is of low strength. Okay, similarly bearing of plates can also happen. Okay, bearing of plates can also happen if the bolt is of very high strength and the plate is of very low strength. Then what happens? The plate which is joined starts to wear. That is, the material here starts to deteriorate, right? ये ऐसा है, ऐसा करके यहाँ पे अगर बोल्ट है तो it starts to stretch. Now bearing failure. Okay. Now another failure is what? Tearing of plates. Tearing of plates means what? Simply the bolted connection किसी plates में है and the यहाँ पे मेरा कनेक्शन एज इट इज जैसा है वैसा ही है, लेकिन क्या हुआ यहाँ पे टेंसाइल फोर्स इतना ज़्यादा है या फिर मटेरियल जो क्रॉस सेक्शन है मेरा स्टील का, दैट फेल्स, ओके, दैट ब्रेक्स डाउन हियर और हियर एनीवेयर, द फेलियर टेक्स प्लेस वेयर इन द प्लेट्स, दैट इज द tearing of plates. Also we can say it as a tensile failure of the plates. Okay, this means the joint has failed. Okay, so this can also happen. Another one is block shear failure. Block shear failure. Block shear failure क्या होता है? Suppose there is a joint like this and these boards are connected very near to the edge. Okay, we are not following the minimum edge distance and distance. Then what can happen here, that this plate can tear along this path. Okay, now you can observe that this as a whole fails as a block and this comes out. और बाहर आने के बाद कैसे दिखेगा? As a breakdown. Okay, so this is known as block shear failure. Okay, now the sixth and last type of failure is tensile failure of bolts. Tensile failure of bolts. Now this is a special condition. Okay, this is special condition because this only happens when the bolt is in tension. Okay, when the bolt is in direct tension. Generally the bolt is in shear. Okay, but in some special cases the bolt comes in tension, and when it comes in direct tension the bolt can fail in tension. Okay, this is a ductile material, it can also fail in tension, right? This is my bolt, and if someone pulls from here and here, it can fail along tension, there may be a tensile failure. Now I can give you an example. Suppose there is a pipeline, okay, and we are connecting two pipes here. This is the junction, okay, and we are connecting here with the help of bolts. Now you can see that if the pressure increases, the pipe will detach here, and when it will try to break, the force experienced in the bolt is what? Tensile force, direct tensile force. So in this case the failure which will take place will be what? Tensile failure of bolts. Another is hanger connection. If you have something like this type of connection, that is, it is attached to some top base or anything, okay, something is hanging down there, उल्टा करके लगाया हुआ है. Now if you pull this, then the force, what force will be acting here? Direct tensile force, and the failure which will take place here will be tensile failure of bolts. Now I have to understand that there are 5 types of failure, and this one is a special case. Okay, so we have to understand that whenever we will design a steel connection using bolted connection, we have to make sure that these failures do not happen. Okay, Now the bearing of plate and tearing of plate and block shear failure, these are taken care, sorry, not tearing of plate, the bearing of plates and the block shear failure, okay, these are taken care by the minimum pitch, minimum edge distance and distance, these by these provisions, okay. IS 800 2007 has already taken care of it. We have to only check the shearing failure of bolts, bearing failure of bolts and the tearing of plates, then we can safely design a bolted connection, okay. उसमें भी बहुत सिंपल है, क्या करना पड़ता है कि शेयरिंग स्ट्रेंथ निकालना पड़ता है कि एक बोल्ट कितना शेयर स्ट्रेंथ ले सकता है, how much bearing strength it can take and how much tensile force a member can take, then we have to take the minimum of it and that will be the design strength, okay. I will show you example, so tension लेने की कोई बात नहीं है, okay. Now we will study the shearing strength of bolt. Shearing strength of bolt, बहुत हो गया theory, अब होगा numerical. Shearing strength of bolts. Now I will write the formula, I will explain it later. VDSB equal to VNSB by gamma MB equals to FUB by root 3 gamma MB into AN into NN, okay. Now VDSB is equal to what? VDSB is the design strength of bearing type bolts in shear. So VDSB equal to VNSB by gamma MB equals to FUB by root 3 gamma MB AN into NN. Now VDSB here is the design strength of bearing type bolts in shear, okay. VNSB is what? Nominal strength of the bearing type bolt in shear. Gamma MB is the partial factor of safety for material for bearing type bolts in equals to, it is equals to 1.25. FUB is the ultimate strength of bolt. AN is the net area, which is equals to 0.78 into the gross area I have told you earlier, and NN is the number of shearing interfaces, okay. Now I will explain it one by one. Design strength is the ultimately the value which we will use for the design of the bolted connections, okay. Nominal strength is nothing but the strength without the factor of safety. Whenever we divide the nominal strength with the proper factor of safety, it becomes the design strength, okay. Now gamma MB, it is a partial factor of safety for material, okay. M denotes material and B denotes bearing type bolts. So gamma MB is the partial factor of safety for material for bearing type बोल्ट्स. याद रखना यहाँ पे स्टील स्ट्रक्चर्स में आपको बहुत टाइप के पार्शियल फैक्टर ऑफ सेफ्टी मिलेंगे. यहाँ पे पैरामीटर्स बहुत ज़्यादा है, इसलिए इट टेंड्स टू बिकम हार्डर देन द आरसीसी डिज़ाइन. वहाँ पैरामीटर्स कम रहते हैं, लेकिन यहाँ पैरामीटर्स बहुत ज़्यादा है, लेकिन इट्स वेरी सिंपल. प्रैक्टिस करते करते बहुत ईजी हो जाता है. नाउ FUB इज द अल्टीमेट स्ट्रेंथ ऑफ द bolt. Remember when I have told you earlier about the grade of bolts, that is the grade is 4.6, then 4.6, that means 4 is the 4 into 100, that is 400. That 400 is the FUB, that is ultimate strength of the bolt. N is the net area, 78% of the gross area, and NN is the number of shearing interfaces. That means if the bolt, how many faces are experiencing the shearing forces. Suppose for this lap joint, the shear can happen only in one plane, okay. Now if it would have been a double cover butt joint, then there would have been what, 2 shearing interfaces. So clearly the NN will be equals to 2. So simply we can say that NN equals to 1 for lap joint and single cover butt joint, and NN equals to 2 for double cover butt joint. Okay, now we will do numerical in the next lecture. Thank you.